Good morning friends and welcome back. Today we will see two important rearrangement with one homework friend that we will see during course of our discussion. The first one is the Favorsky rearrangement friends. What is the identity of this rearrangement friends? It is rearrangement induced by base or electron rich side friends, right? We know that organic base, they are having more electron density and ready to donate the electrons friends, right? So let us we see the Favorsky rearrangement. It is base catalyzed, base is reproduced friend at the end as a catalyst. It is base catalyzed rearrangement of alpha haloketone to form carboxylic acid derivative friend. So this is the ketone and adjacent carbon is my alpha carbon friend. So alpha haloketone in the presence of suppose sodium ethoxide or methoxide, which is your organic base, getting converted into carboxylic acid derivative. See, COOR is your ester part with the rearrangement of this particular carbon friends here, right? So we will see how it is done in a mechanism friend. So be with me in the mechanism part. Okay, just we saw that in the previous slide, RONA, right? Suppose I write sodium ethoxide, right? C2H5ONA is your organic base. In that, C2H5O will be the minus part, Na will be the plus part. So this is the organic base portion friend, right? And here this is the C double bond O, alpha halo group is there, and you have on other side one organic group friend, from which this ethoxide ion is going to trap this proton friend. So there is a loss of alcohol, but as this carbon receives the electron, because hydrogen is left as a proton, what will happen? This is going to form a minus charge friend, right? Now be with me friend, what I am doing, I will catch this C double bond O in my left hand, and if I will try to pull it down friend, right, towards what I have written 2. So as a result what will happen, still connection will be as it is, but this carbon and this carbon you will find that they come close to each other, remains as they are. This side from like this friend, I am trying to pull it like this, C double bond O. Therefore these two carbons, right, they are little closer, and it will be easy for you to understand the electron rich site is going to attack friends to this particular carbon. So there is a formation of a C carbon carbon single bond and C double bond, as I have pulled down, right, it is somewhere here, but during that attack the Cl is left as Cl minus friends, right? So this is the intermediate structure 3, and if I tick mark, this is carbon 1, carbon 2 and carbon 3, it is cyclopropane type of derivative friend, isn't it? Now second molecule of ethoxide ion, or you can say RCONA, from that RO minus part is going to attack to this particular carbonyl carbon, right? So when it attacks this on this carbon, the pi bond open up and electron goes to the oxygen. So oxygen is now negatively charged. This is the negative charge friend. Excess electrons are there with this oxygen, and OR prime from the organic base is now connected with the ORS with the carbon. So this is your structure number 4, intermediate structure number 4 friend. Now listen to me. I have written two different words, A and B friend. How I am going to use this A and B, that will be explained in the next slide. These are the two side, A side, another one B side friend, right? Okay, so now the back donation of this electron, so what will happen, this carbon C double bond O is going to form, but then this carbon becomes pentavalent, therefore this particular bond opens up and the electron goes to this particular carbon. So this carbon has become minus charge, right, as structure number 5. So ring opening is taking place here from side A. Friend, A or B, if there is a symmetrical cyclopropanone derivative here, doesn't matter, right? Because whether it opens from side A, then also there is a formation of carbanionic carbon. All other parts are the same. That is why if it opens up from side B, then also there is a formation of similar carbanionic carbon on the other side, right? Okay. Now in the next part, friend, this is a proton, right, is going to be trapped by this particular carbanionic carbon, friend, in structure number 5. So there is a formation of ester derivative, friend. See, alpha haloketone is getting converted into ester derivative, right, in the presence of organic base, friend. This is oral identity of Favorsky rearrangement, friend. Okay. So this little explanation is there in the next slide, friends. Okay. See, as I said, today I am going to give you one homework, right? Favorsky rearrangement, it involves migration to electron rich carbon atom, friends, right? In symmetrical cyclopropane, as an intermediate, 2 alpha carbon atoms are equivalent. Therefore, ring opening taking place via route A or from side A or B gives the same carbon ion, friend. However, when there is unsymmetrical cyclopropane ring opens, then which side will be favor, A side or B side? It will be decided by, in such cases, the ring opening will be such that more stable carbanionic carbon out of 2 possible is favored. And friend, listen to me, carbanionic carbon stability order is what? Primary is more stable than secondary, and tertiary is the least stable if you consider that carbanic carbon is attached with the organic groups, electron donating groups, right? Okay. So this was the little bit about the Favorsky reaction, rearrangement and its mechanism, friend. Now listen to me, part of your homework, friend. The homework is depending upon the marks. How many marks is assigned by the examiner? Suppose I say explain Favorsky rearrangement with suitable reaction mechanism, right, or mechanism with suitable example. You need not to write the second mechanism here, but example you can quote. What is this example and what is the homework? Wait, alpha alpha may be dihaloalkanes. Both these halogens are connected with the alpha carbon, possible. Alpha alpha prime, this example is this alpha alpha prime dihaloalkane leads to formation of alpha beta unsaturated ester, friend. I will explain little bit about. See, this is our carbonyl group. Suppose I say it is alpha, friend, then the opposite side it has to be alpha prime, friend. Alpha alpha dash, right? Dihaloalkane, here it is 2 bromine atoms are there, right? So this particular derivative systematically it is known as 1,3 dibromo, 1,3 dibromo. So this is your carbon 1, this is carbon 2, this is your carbon 3, and in this one of the carbon is carbon 4, right, and one is connected with this carbon 3. So 1,3 dibromo, this is a 1,3 dibromo 3 methyl, because this carbon contains one of the methyl group here, and total 4 carbon atoms are there. So 3 methyl butane 2 on. If this is the starting material, right, so next let examination they will try to understand your understanding of the mechanism part. They will write this is the starting material, sodium methoxide or sodium methoxide. This is organic base in the presence of ether. What are the possible product? Out of that you should be able to get that this is nothing but methyl, this is the methyl ester, methyl 3 methyl, because this is carbon 1, 2, this is 3, it has one additional methyl group, right? 3 methyl crotonoate. Crotonic acid is what? Ca3 CH2 CH double bond CHCOH, but this carbon which is carbon number 3 has 2 methyl group, therefore it is 3 methyl crotonic acid derivative. This methyl is connected with the ester part, methyl 3-methyl crotanoate, friend. Now your homework. If I ask how 1,3-dibromo 3-methylbutane 2-on, that means this starting material gets converted into methyl 3-methyl crotanoate. Can you use the previous slide and design the steps, friends? This is your homework. So, homework, I know that only few of you are going to stretch your mind. So, immediately I am giving you this video back to back. I will also send you one slide which is homework done for you, right? But good student will not look at the slide which I am sending. You try your best and then you compare what is not fitting in your eyes. We will discuss in the live session as soon as it is possible. In this case, ring opening involves elimination of halide ions, right? Both these halide ions are going to be lost, and this is your hint, friend, also. Okay, I'll show you in the homework slide, friend. We used to have one professor, very good organic chemistry teacher, friend, right? But he has very fond of the work done by this Nobel Prize winning scientist Wittig rearrangement. Scientist name is Wittig, and therefore we also used to study one or the other part of the Wittig contributed in our chemistry. So we have this information that more than one paper is set, but if our sir is going to set, directly or indirectly he is going to ask about the chemistry established by scientist Wittig. Very nice. Let us try to see what Wittig rearrangement has to say here, for friends, for us, right? So it is base catalyzed rearrangement of an ether. Ether, friends, starting material is ether to an alcohol. So what is the identity of Wittig rearrangement? Base catalyzed conversion of an ether to an alcohol via 1,2 shift, which is known as Wittig rearrangement, friend. Okay, let us try to take a rearrangement of benzyl and aryl ethers in the presence of strong base such as alkyl lithium, right? Sometimes aryl lithium is also used. It is known as Wittig rearrangement, friend. So all the name reactions you should be able to define in 2 lines. What is rearrangement? What is Favorsky rearrangement? What is Curtius rearrangement? Like that overall, right? Okay, benzyl phenyl ether, that is compound number 1. This is the benzyl part, this is phenyl part, this is ether moiety. Upon treatment with sodium at 100 degree centigrade temperature is going to give you benzhydrol, friend. This structure is known as benzhydrol. So actually what has happened, friend, if you look at this phenyl part has migrated over this, right, with one hydrogen less, and that has combined with this OH form. So ether has converted into alcohol, friend, and actually looking it is secondary alcohol, isn't it? Structure number 2. Okay, friends, right? If you want to make your job easy, because to me also I have more, what you can say, a kind of respect towards the work done by Wittig. So directly or indirectly you can say it is important for internal or external examination if Atul sir has to set the paper. A powerful base such as phenyl lithium or sodamide, right, is required to abstract a proton from ether. What is ether? It is your starting material, right? For example, a strong base like phenyl lithium abstracts a proton from benzyl methyl ether, compound number 3. So this is benzyl group, methyl ether. In the presence of a strong base phenyl lithium, this one of this hydrogen is lost in the form of a proton. When hydrogen is lost in the form of proton, that substrate getting the excess electron, because hydrogen gives away electron, take, therefore that carbon becomes negatively charged. Structure number 4, right, that offers the conjugate base. This is the conjugate base, that is of starting material, structure number 4. Now 1,2-methyl shift from oxygen without a pair of electron to adjacent carbon atom, right, gives a more stable alkoxide anion, friend. There is a presence of anion here, but in the next step what is going to happen? This particular group, right, 1,2-methyl shift from oxygen without a pair of electron. This methyl group says that let me live without pair of electron, because where I am going to land, that carbon has already excess of electrons. Therefore, it is 1,2 shift oxygen to adjacent carbon atom, which is connected to this ether oxygen. Not only that, friends, this methyl left, it was a bond between this oxygen and methyl without its electron. So this oxygen becomes negatively charged, and it is of course counterbalanced by lithium from the phenyl lithium, friend. So this is structure number 5, friends, right. Now in the presence of water, friend, right, there is a proton abstraction, friends, right. Therefore, this O minus traps a proton, becomes OH. This is the structure number 6. It is your alcohol. So benzyl methyl ether getting converted into alcohol via use of phenyl lithium, which also involves 1,2-methyl shift from one house to another house. The methyl has migrated without its pair of electron. Similarly, dibenzyl ether, that is structure number 7. This is benzyl group. This is also same. Only one thing I have written here, instead of C6H5 PH, otherwise it is same. Dibenzyl ether gives 1,2-diphenyl ethanol, right. That is benzyl phenyl methanol, that is structure number 8, upon treatment with phenyl lithium. This is a strong base in the presence of ether. So what will happen? This is symmetrical ether, friends. So both this carbon or this side carbon, they are equivalent, friend. So phenyl lithium, right, allows abstraction of a proton from this CH2 part. So anion is formed, counterbalanced by Li plus, lithium plus. Now this is minus charge, therefore this group, friends, right, migrates on this carbon without pair of electron, and it is easy for you to understand that with PH I have migrated and the electron remains with oxygen. So this is minus charge balanced by lithium, and you know that in the presence of proton donor, right, in the previous example we saw that there is a, what you can say, water here, abstraction of a proton from the suitable source, it is going to form alcohol, friend, right. And this is nothing but 1,2-diphenyl ethanol. If you say this is carbon number 1 of ethanol, this is carbon number 2, both carbon they have C6H5, right. So 1,2-diphenyl ethanol, friend, clear. This is the benzyl group, the other structure, benzyl group connected to this carbon. This is the carbon of methanol, for example, and another group is C6H5. So this is the benzyl group connected to methyl carbon. Phenyl group is also connected. So you can say it is methanol, the another name of the same compound, friend, right. So this is migratory aptitude, friends, now, right. The migratory aptitude of various group, right, study found that they are in the following order. Allyl group migrates faster, then benzyl, then methyl and ethyl, almost same, even para-nitrophenyl also, then phenyl, etc., friend. Scientist Wittig compared the rate of rearrangement of, listen to me, benzhydryl methyl ether, benzhydryl methyl ether, this is benzhydryl methyl ether, and benzhydryl tert butyl ether, this is benzhydryl, But in the first, that is structure number 9, methyl ether. So this is methyl group. Here third butyl ether. So this is the third butyl group, friend. And phenyl lithium, tetrahydrofuran, etc. They are both are going to give secondary alcohol. But what was the observation? Wittig found that it was the migration of methyl is faster than tertiary butyl. So this reaction will be the faster compared to this particular reaction because there is a tertiary butyl group, friends. Okay. Okay, it was found that the migration of methyl group just in the previous slide is much faster than the tertiary butyl group. Okay. So there is one more view to look at the similar kind of the rearrangement. This is radical pathway. There is enough evidence to support the radical pair mechanism for Wittig rearrangement, where the migrating group is alkyl or aryl, but radical pair mechanism, radical means dots, free radicals, and pair means there will be two such dots, friends, right? Okay. So this is the phenyl, there is a starting metal RCH2O R prime, suppose here. In the presence of phenyl lithium, etc., a proton is abstracted, it has become what? Anion, friend. Now be with me, friend. This part R has to migrate, R prime has to migrate, but wait, this bond I will break in such a way that the oxygen is carrying one dot, the R prime is carrying one dot. Therefore, see here, this is momentary arrangement to understand that oxygen has one dot and R prime, right, there is also one dot, right. So what is happening, friend? There is a possibility that this anion migrates and this dot migrates to this carbon atom. So this is another possible resonating form, friend, in a solvent case. Now free electron is with the central carbon atom at CH dot and anion is on oxygen atom. Possible, friend. Now still you have this particular R with one electron, friend. So it is going to combine with this CH dot. So there is a formation of pure oxygen with the anion because R has already combined with this carbon with it was having a dot. And you know that there is going to be H plus in the reaction medium. O minus is going to trap this proton to form alcohol. But this reaction I explained is with what? Radical pair, friend, right. And further there are some observation connected to this rearrangement, evidence in favor of radical pair mechanism. Number 1, migratory aptitudes of various groups are in order of free radical stabilities. When you take R, R prime, etc., radicals are formed, then also the overall rate of reaction or the Wittig rearrangement was favored by the radicals which are formed. The stability of radical are the evidence. What it says? Primary more stable, then secondary radical, and then the tertiary one. So stability of radical formed are again favoring this kind of radical pathway to understand this rearrangement. Second, the rearrangement is intramolecular, friend. See here, and there is one very important evidence that will be the last slide. This R, that is the organic group, it was already there, friend, and it has migrated to this carbon, but nobody is coming out of, right, from the other substrate, friend. So it is a intramolecular type. The third one is aldehydes are obtained as the side product, right. All these are in favor of radical pair mechanism. However, when allyl group migrates, the concerted mechanism is believed to be operative, friend. You know what is the allyl group? Groups with the double bond, right. So in such cases, the ether with the allyl groups right? They would like to prefer the other part, concerted mechanism, which is there in the next slide. See friends, you have the not one but two allyl part. Friends, be with me. Every time when I talk about this reaction mechanism, I have to be also little bit, friend, little bit careful. What and how, I will explain. First of all, phenyl lithium, it is the ether which is symmetrical one. So this carbon is going to lose the proton, anion is formed, right? Now listen to me, friend. This carbon wants to leave the company of this oxygen, friend. What it says that we have 2 electron here, but you take away the electron, right? But it happens only when this carbanionic carbon extends its electron to this carbon. Then and then these 2 electrons are going to be with the oxygen, and therefore friends, please be with me, right? Actually this part is going to migrate from the top and lands on this carbon atom, right? And therefore the bottom part is, it is this line is at the bottom, friend, and the oxygen has the minus charge, friend. Have you understood this step? Right, 1 2 shift. And friend, up to this, then I have not to say that you are going to trap a proton from outside, giving you the alcohol, friend, right? So this is the, what you can say, concerted path other than the, what you can say, radical pathway, which is operative if the allyl groups are going to be migrate. I am very happy to share that this kind of what you can say, the evidences also helps teachers to have more interest. What is this crossover experiment, friends? Right, crossover means you are crossing, right, your boundaries. So they thought that there is a possibility of this kind of cross connection, but at the end we will see what is happening actually. So let us try to understand what is this crossover experiment. In the following reaction, 1 is also your starting material. You are taking a round bottom flask. This is your starting material, ether for Wittig rearrangement. But there is one R with the star asterisk. That means a special sign, radioactive methyl group. Think about, right? Actually it will be easy for you to understand with this asterisk. In the same round bottom flask, you are taking compound number 2. This is the compound number 2, friends. See here, dibenzyl ether, isn't it? Both are going to be treated in a same round bottom path, round bottom flask with organic base. Here it is butyl lithium in the presence of acidic medium. So what is the expected result? Expected result is that this will get anion. You know that how to get anion, oxygen, right? First of all, here there is a formation, loss of a proton, this becomes minus. Similarly from this side also, one of the proton, because they are present together, this becomes minus. When 1 2 shift happens, you know that it is the methyl group which is going to be migrated on the adjacent carbon. But wait, scientists were expecting that in the same way this part is going to be migrated here. Is it possible that it will jump to this one? And is it possible that methyl group is going to jump to this anion? The result found, no, it is not happening. Only methyl group which it was connected with the starting material 1 with the nitro group in the para has migrated here. See, this is the product number 3. And compound number 2, this part has migrated only to this carbon atom. No methyl has came to substrate 2, friend. So cross connection is not happening during the migration, friend, right? How nice, friends, they are very smart, isn't it? So the product 3 and 4 were analyzed, and they were found that even we are trying to use the, what you can say, the labeled radioactive carbon when 1 and 2 are rearranged together in the presence of beta lithium, no isotopic labeling or radioactivity is found in the product number 4. All the radioactive carbon, labeled carbon, remains with the starting material 1, which gives you 3. If little amount has gone right this side, then you can say there is a cross kind of what you can say interaction. But as it occurs in the same substrate, 1 remains with 1 after migration, also giving only product 3. All the radioactive carbon is here in 3. 2, all the migration atoms groups remains with the substrate 2, giving you 4. No radioactive groups coming into 4. This indicates that the rearrangement is of intramolecular in nature, friend, right? So this is how we are getting the understanding the Wittig rearrangement is purely of intramolecular type, friends. Thank you. Soon I will be sending the homework slide, friend.